All right. Good afternoon, all, and welcome to VisugXL, the second edition of our annual conference. I want to start by expressing my hope that everyone is safe and doing well. And with this VisugXL conference, we are trying to bring you some fun and also some extra knowledge in these challenging times. During the different sessions that we have, you will see that we have both in this stage window a chat and a Q&A. So we would like to ask you that any questions that you may have for the session during the session, that you post those in the Q&A, and any public conversation about this session, you can do that in the chat window. Also, we are there's going to be an automatic rating system that kicks in after the session has finished. So we'd like to ask you to complete the session survey. You can do that after the session has finished. And now, without further ado, I want to kick things off and start the first session. And I want to welcome to stage one, which is where you're at this point, Lode from Access. Lode will give us some insights in the WebRTC protocol. I think it's something that is pretty current and pretty actual with all the things that we've been doing, all this Zoom and Teams meetings that we have been doing in the last couple of months. Lode, good luck.
All right, thank you. So first off, let me start sharing my screen. All right. So, as Jill said, I'm going to introduce you to WebRTC. It's a technology we've been using all the time, basically during Corona, but possibly also before Corona. Some examples of applications that use WebRTC are Google Hangouts, WhatsApp, Facebook Messenger, Zoom, Skype for Web, or even Microsoft Teams, possibly even Python, I'm not sure. Even though we're using them on a daily basis, we often don't know how they work and why we use them. So that's what you can expect from this talk. I'm going to do a short deep dive, pretty theoretically, on how WebRTC works. And afterwards, I'll be doing a live demo in plain JavaScript so that you can run it in basically any browser. Well, it should work. Depends on the browser, obviously. And we'll be running a .NET backend. But I'm not going to go into the .NET backend too deep. I'm basically just going to focus on the JavaScript part. The backend is very generic, so you should be able to apply it in other programming languages as well. So first off, what's WebRTC? Well, WebRTC stands for Web Real-Time Communication. It's open source, it's free, and you can basically use it on any device that has a web browser, like smartphones, laptops, desktops, tablets, and consoles. As long as the device is a browser, you can use it. Well, making sure that the device is pretty recent, though, because I don't expect you to use it on a PlayStation 1 or anything, for example. Sorry, PlayStation 2, that has what capabilities. Now, real-time communication is pretty abstract. There's a lot of things that you can imagine by saying real-time communication. Well, what does that practically mean? Well, the same thing as I said before. You can basically send everything over WebRTC that you want. But usually this is about media data like photos and images, but also live streaming video, live streaming audio, sharing files, and creating chat rooms or chatting with your friends. The next thing that's important to know is that we're talking about peer-to-peer in WebRTC. Well, in its most base form, that's what we're going to focus on most of the time today. And it uses SCTP. Well, SCTP is a protocol that's basically a hybrid between UDP and TCP, but it's not too important to know about. What is more important is the fact that it's peer-to-peer. So in the future, the idea would be to focus, to move to QUIC instead of STTP, which will also be used in HTTP3 or HTTP over QUIC. But that's something more in the future. We're going to use the SCTP part. All right, so that's a very, very brief introduction onto what WebRTC is and what it stands for and so on. What are the requirements for you to run WebRTC in your web application? So the first thing you're going to need is a web browser, or more specifically, 2 web browsers. That's important because you want to call or talk to something or someone. Just having a single web browser or a single tab in a web browser is pretty useless. The next thing you're going to need is a turn or a stun server. I'll get into that later, what that is, and a signaling server. I'll get into that more, go into more detail about that as well. So on the right side, you can see the three web APIs that we're going to use, which are the media stream and the RTC peer connection. Well, we could use the RTC data channel as well in the browser, but we're not going to use that. That's mostly used for doing chatting, but we're only going to use video and audio for now. All right, onto the stun and turn server. What are those? Well, the stun server stands for Session Traversal Utilities for NAT, and turn stands for Traversal using RelayNet. That doesn't say anything to you probably, so some more explanations. What they do, they're basically responsible for telling a browser what my public IP is and what a way is for people to connect to me. Because it is important that data gets from the other side, the other browser, to your browser, and the other way around as well. But there are a few key differences. The first thing to know is that stun is usually for public networks or less secured networks. Why is that? Because it directly connects you peer-to-peer. It means that every single type of data is sent directly between you two, and there's no server in between involved. That's what you should try first. It usually works, depends, but if you're on a company network, that's probably not going to work, because a company network is probably going to stop you from using peer-to-peer connections. And you can configure it in your browser as a fallback method for the stun server, which is a pretty good idea if you're building a basic video or audio chatting application. One thing you see on those two sides is ICE. I think most of you don't know what ICE is. ICE is, well, it stands for Interactive Connectivity Establishment, another term that probably doesn't say anything to you, but it's a framework that allows WebRTC to overcome a lot of real-world networking complexities. The job of ICE in both those situations is the way to connect to the clients, to describe the way or find the best path for the two browsers to connect to each other. But it also works where a direct connection is not possible, so for turn, for example. Now, a little more practical. We're not going to code just yet, but I'm going to describe to you on what a scheme for a simple WebRTC web application could look like, and what we're going to build later on today. Well, as I said, the first two things you need are two browsers, two clients that want to talk to each other. This example is also for media and audio, video and audio chatting. The first thing those browsers are going to do is they're going to talk to the Navigator API in the browser. What does that mean? They're going to ask the browser, hey, I want to get some media from the user, and I'm going to say, okay, it has to have a video and it has to have audio. The two things you see are both constraints. So if one of the constraints fails, so for example, the user doesn't have a webcam, but he does have a mic, or the other way around, it's not going to work. You're going to get an error. If it does work, you end up with a media object, a media stream object that you can use to show yourself the video or to start streaming video to someone else. Very basic. This code also invokes the method that asks you the question whether you want to allow to share your microphone and your camera. So that's the annoying pop-up you get. Do note that some browser policies, once you click this once, they will also always allow your microphone and camera access, which could be a privacy issue. All right, so now we've captured media. We can basically start sending it, but first we have to find out who we are ourselves, not in a deep way, but in a networking way. You want to ask yourself, what's my public IP address, and what's a way for people to connect to me? And that's when the turn and stun server is coming. So the stun server is going to try to, okay, let's try to set up a direct connection to yourself. and the turn server is going to try to do it as a relay. For now, we're going to assume that we're using a stun server, and we'll include the turn server a little bit later on. So we have our media. The client 1 starts a session, so it's going to send a message to a signaling server, which I'll go into more detail about later as well. That signaling server is going to forward a message to set up a call to client 2, after we've received the info from our stun and turn server, of course. Then afterwards, the same thing is going to happen on client 2. It's going to reply back to client 1, hey, okay, this is a way you can connect to me. But it's probably pretty unclear what these messages actually mean. So this is what a message looks like, a session description looks like. Well, there are a few things that you can read from within this message. The first thing is that the type is offer and it's SDP. Now, what does SDP stand for? It's Session Description Protocol, and it's a standard that's created to describe peer-to-peer connections. That's right, for people who know SDP, it's the same protocol used for voice over IP, for example. Now, what does this contain? It contains codecs, source addresses, timing information about the video and audio to keep it in sync, and so on and so forth. Now, this is a standard to describe the connections, but there are 2 types of messages of these. The first thing I already talked about is the offer. So there are two messages that are being sent. The first one is the offer. You can see it as a person trying to call you and you receiving the call. And the second one that's gonna send back to the client is the answer. Both of them describing the same information. What codec am I using? What timing information is there about my audio and video? And what IP address am I using, for example? And a lot more information that's not that important for now. After we've done this, we end up with a stable connection between 2 browsers. So I'm going to send a message, hey, I want to talk to you. This is the way to connect to me. The other guy's going to respond, okay, I'm accepting the call, and this is the way you can talk to me. Well, after that, you end up with a media path. And then the signaling server is not going to do anything anymore. The media path is going to be directly between the two clients, so it's going to be a peer-to-peer connection between the 2 clients. And if that's not going to work, it's going to fall back to the turn server, and it's basically going to be a relay between the 2. So that ends up being a way to fix connectivity issues when you're on company networks as well. So if you want to make sure that your application always allows people to connect to your web application, make sure you're trying to use a turn server instead of a stun server, or at least have it as a backup server. I'm going to show you later on how you can configure it as a backup server as well. Now, there's still one thing in this whole scheme that I've not talked about just yet, which is the signaling server. Well, I talked about the connection being created, but how is the connection created? How are the messages sent to each other? Well, it's actually pretty simple. The signaling server just forwards the message that you send over it to the correct client. Why is there a signaling server needed? Because your browser doesn't know who it can talk to and the way it can talk to someone else. There's no discovery built into a browser to allow you to discover people on another network, maybe even in another country, to communicate to directly. So that's what the signaling server is for. It's basically a stateful application that keeps a state of your users or groups that are grouped together, so that you can you can communicate to each other. Well, let's use a more real-life example for this. Let's say we want to meet up with our friends. Well, we can't do that right now, obviously, because of the Corona crisis. But let's assume that we are in a normal situation right now. A place that I usually use to talk to friends or to meet up is Facebook Messenger. So let's use that as an example. When I send a message to a friend of mine when I say, hey, do you want to meet up at the restaurant? And the guy's going to reply to me, and then we're going to meet up. In that situation, Facebook is going to be the signaling server, because every message that we send to each other is going to go over it, and it gives us the information about who's online and going to do the initial setup between the communication for us. The session offers and the session answers that I talked about earlier are the messages that we're sending, like, hey, do you want to meet up? What time, where, and so on. And when we're actually meeting, that's the peer-to-peer connection. Then we're actually together and we're communicating to each other directly, and Facebook has nothing to do with it anymore. That's basically it. Now, the architecture I just described is very simple. So it's just two browsers talking to each other directly. It's called the mesh architecture. It's the most simple way to implement WebRTC. It's what we're going to focus on most of the time right now. So here's some more information about it. The mesh architecture. There are a few positives about it. Like, it's simple, but it's very low cost. It doesn't use any server resources. What you have to note, though, is that it probably exposes your public IP address when you're sending it in a message to your other party. And it's not made to scale. Like, yeah, you do have to note that every time you connect to another user in your group session, for example, you have to create another connection, which means that when you have 25 users, you're gonna probably have around 300 connections, because every client has to forward its own stream to all other users, which climbs up really, really fastly. Another really bad thing about this is the fact that every browser has to support the same codecs. For example, client 1 wants to use VP8 and client 2 wants to use H.264, and they don't support the other codecs. It's not going to work. You're not going to see each other's video. It's just going to fail. So you can see that it's very easy to set it up. It's going to be fast, but there are a lot of complications when using it. So I do not recommend to use it in a production environment when you want to use WebRTC. A better solution for these issues would be the selective forwarding architecture. So there's two other ways to implement WebRTC that I want to talk to you about. First off, the selective forwarding architecture. It probably says quite a lot when you hear it, just like most of the other terms I talked about earlier, right? So here's another schematic. The biggest difference between the mesh architecture and the selective forwarding architecture is that the server is going to take a lot of load of the client itself. Comparing it to our earlier model, the client was always responsible for uploading the data and downloading it for every client in its session. In this use case, the client will only upload its own stream once, and all the other guys, and will download the other guy's streams once. In this situation, we'll end up having 3 connections. So you might be thinking right now, okay, these are more connections that we would have in the previous architecture scheme. But what you have to note is the fact that that we previously had to upload and download to everyone, and we only have to upload once and download the rest. So the bandwidth usage is going to be a lot lower than in our previous schematic. Even though the amount of connections will be higher, we're talking about n to the power of 2 here. So it's going to increase pretty rapidly as well. So if this is basically better in every way, why would you not go for it straight away? Well, the server is going to get a pretty heavy load within each stream and has to forward it to every other client. It's a lot more complex to set up as well. I can show you later, well, I am going to show you later that the first architecture you can basically set up with about 100 lines of code, I think. This is a lot more complicated. Plus, the server that you're running also has to be maintained. On the other side, it allows you to do a lot more things with your streams as well. You can monitor bandwidth, you can scale frame rates and resolutions when you want, you can even record it if you want. Yet, you have to note that even though it's going to work pretty efficiently, once you start doing these things like scaling or recording, it's going to get a lot harder for the server as well, because you're going to have to start decoding packets, which is going to take a lot of CPU or GPU time. You could also abuse this to just avoid using turn servers, but if you just want to use it for routing, I'd suggest just looking at the turn server first, unless you're aspiring to have a pretty big user base. All right, that was the selective forwarding architecture. The next one I want to talk about is mixing forwarding. It's the last architecture I want to talk to you about before we get into a hands-on demo. Now, it doesn't say a lot either, but mixing it does say quite a lot in my opinion. Let's show you another schematic. What does mixing mean? Well, the mixing means that it's going to set up one bidirectional stream per client. It's going to combine all the streams that are coming in into one single stream for every client. It's going to be one connection for every client to upload and download to. So it's actually going to mix your media together, and it's actually going to combine all the audio and video resources. But yeah, you can hear me coming already. You're going to have to depacketize every packet. You're going to have to decode it. You're going to have to mix it and re-encode it all the time, every single thing that comes in. But the biggest advantage is you can basically support any codec there is, and every client there is on there can also, that's trying to connect and use your platform, can also connect and use your platform, because otherwise other devices might not support it and it might not work. For example, what you could do with this is, let's say if you have 2 users, you could allow them to stream in full 4K, record in 4K, and stream back, and allow them to watch in 4K. While when you have 50 users, you could transcode it all to 720p, stream it to 720p, but still do the recordings in 4K, so that everyone has a pretty lag-free experience. Well, the biggest reason why you wouldn't go for this architecture is obviously because it's very, very expensive to run this. Okay, so we just talked about 3 architectures. You might be wondering which one should I use. As always, it really depends on what you're trying to build. It depends if you need the functionality to record, to transcode, if you want to monitor bandwidth, if you want to scale, all those things are really important. The ideal solution that I see for video calling applications is probably a hybrid architecture. So you see this happening a lot as well. Like when you have small sessions, you're going to use a mesh architecture. It doesn't allow you to record. It's probably a free version of your application as well, and it's pretty low speed. There could be lag, and there could be a lot of frame drops, but that's okay. On an average, well, a medium-sized group, you could switch to a selective forwarding architecture. It allows you to record. It's not peer-to-peer anymore, so it's going to scale a lot better. But if you're aiming to go really, really big and you want to support like a lot of features, the mixing forwarding architecture is probably the best one for you and the one you want to use. Okay, so that was the theoretical part of my talk. Let's try to go hands-on. What are we going to build? I'm going to say this again. We're going to build a mesh architecture application that allows you to join a room and see each other's video and talk to each other. That's basically the thing that we're going to use. We're not going to go into things like selecting the right video and audio source, because that's going to bring us too far. If you want, my code is available on github.com/Lode Kennes/WebRTC demo. And I also have a live version here that we can check out together later. Okay. So I have Visual Studio Code open. If you were to clone my repository, there is a folder called client in there, which you can open. After opening the client folder, you're going to find a few things. The first thing we're going to look at is the index.html file. The index.html file contains an empty style.css. It contains a setup button, setup div that contains our text box to enter a room number and a start button to start our video. Then we also have a video tag, a video element that contains our own video. It's going to autoplay and it's muted because we don't want to hear ourselves. Really annoying. I've had that a few times. And another container that has all the other videos of clients. But we're not going to touch the HTML anymore. That should be fine. Let's look at your JavaScript. There's a few things in here that we can note when we open it. The first thing is we have a variable called pure connection config, which contains ICE servers. We talked about ICE earlier, which is a way to allow people to connect to each other. It's a protocol to find the best path for people to connect. And we can define a few URLs in there. We're going to use a few public stun servers. There are a few public stun servers because, well, there's no reason why they shouldn't be public. It's just a way. It's just a way to allow people to talk to each other that you can use. They're not paid either. You can just use them. They will be tried in the same order as they're listed. So should the first one be down, it'll automatically switch to the second one as well. Next, we have a well, this is going to be a dictionary where we're keeping all our RTC peer connections in. We're going to use SignalR to talk to our server, which is hosted online, that we can use to talk. We're going to listen to a client join, so when someone joins our room, we're going to listen to a signal event, which is basically when there's either an SDP or an ICE event coming in. We're also going to listen to a client left event, which I already implemented for you. What this does is when someone leaves, you don't want the video to stay there and freeze, you want it to be gone. And then we also have a start button. What this is going to do, this is going to get the room ID from the text box. This is going to remove the element setup because you don't want to enable it anymore. And then it's going to start a hub connection, and it's going to say, hey, I joined this room with room ID this that you filled in the text box earlier. But there are a few things that we're going to have to fix before we can get this to work. Let's first start the server. So first what you want to do is npm install, and then npm start. The reason I use npm and not just open a browser is because it requires you to use HTTPS, so I made a self-signed certificate. I have noted that some Mac browsers really complain about it and don't allow you to continue, but it should work in Firefox. Okay, so let's get going. The first thing we're going to do is get the user's media. So we're going to get the user stream. The way we're going to do this is, well, as I talked to you about earlier, just getting the user stream from the browser's API. We can do that by awaiting any promise, which contains a resolve and a reject as per usual. Next, we can talk to the Navigator API, navigator.getUserMedia. This is all natively supported by the browser. And then we can supply the constraints. So we want video, but we also want audio, because that's what we want to send. Oh, that's a typo. Because we don't want users to join without video, without audio, just for this demo's sake. We could allow that in the future, though, if we wanted to. If it works, then we're going to receive the media stream. If it doesn't work, we're going to receive an error. Well, basically what we're going to do, we're just going to log the error, and then we're going to pass it back up to reject that. If it does work, though, then we're going to assign the stream variable with our media stream, and we're going to set the media stream in our video object that we created in HTML. So we can get this object in JavaScript and then assign our stream that we set up here to it. So we're going to do that by document.getElementById, own video, and then we're just going to set the source object to stream. And that's it. So we've basically done our first thing. Now let me try to refresh now. Let me type in A and start. You're going to see me twice now. It works. Okay, let me refresh because it's pretty annoying to look at myself all the time as well. Let's get on to the second part. So I think this is pretty easy to understand. You're just waiting for the browser to give you a media stream with the things you're asking for. And if it doesn't work, you're going to get an error. If it does work, you're getting a stream that you can assign to your video item. All right. The next thing we're going to look at is client join. Let's say someone joins your room. what you want to end up doing is negotiating, hey, what is the best way for me to connect to you? And you also want to set up the stream if it actually succeeded. We've got a few variables coming in here. So first thing is the ID of the user that joined. It's just a random GUID. We have the amount of users that's in the call, and we have a list of the clients that's in the call. So we're gonna loop through all the clients for socket ID of clients. The first thing we're gonna do is we're gonna check if we already have user in our dictionary that I created earlier. So if RTC peer connections, socket ID is not undefined, or the socket ID is my own. Well, this basically shouldn't happen, but it's never bad to, you know, better safe than sorry, right? Connection ID. Then we're just going to continue. We're going to skip that client. Otherwise, we're going to create a new connection, which is a new RTC peer connection with our peer connection config, which is the list of stun servers that we created earlier. And then we're going to assign that to our dictionary as well. So we're going to add socket ID equals a new object, and we're going to include our connection in it. Okay, so now we have our basic connection created. Let's now see how we can reply to events that end up coming in from this connection. So there's a few things we want to listen for. The first one is on ICE candidate. What does this do? On ICE candidate, basically, every time you have a new ICE candidate, which is a new possible way for a person to connect to you, you're going to want to send it over and let the other person try it out for you to, hey, okay, you possibly can connect to me this way. So that's what we're going to do. Async function event. Now, you're going to get into this multiple times because you're going to keep retrying new candidates until you found one that actually works. The way you're going to know that it actually worked is when event.candidate is null. So we could implement some kind of error here, like, hey, we tried a few ways to connect to the other person, but it seems like it's not going to work. So yeah, try something else. Otherwise, await up connection.send. So we're going to send something over to the other user. It's not with a capital. Okay, signal. So the type of message we're going to send is signal, which is what we're subscribing to here later on. So what are we going to send over? We're going to send the message to the person that just joined the room. Sorry, so to the person that we just created. And then we're going to reply with a JSON string. So it's directly forwarding a string to the other client that he can parse on its own. We're going to send over the candidate. That's basically it. Now you're negotiating ICE. Pretty easy. The next thing we want to talk about is, okay, what if everything worked? Then we're going to get an on-add stream event. So when a stream has been added and you've successfully communicated with each other and a stream has been set up, you're going to go into that event, and then you can start assigning your new video stream that you just created or that you just received to a new video object, assign it to our container, and start actually playing it in the browser. Here you're going to get a new event. Then the first thing we're going to do is assign the stream to our dictionary object that we created earlier. So let's just loop through our dictionary that we have. We're going to say if key and socket ID. Put in the new one that just came in. We're going to say RTC peer connections key dot stream equals event dot stream. All right. So now we assign it, and we can break because it's a dictionary. We're not going to go into that twice. The next thing we're going to do is we're going to get our container, so the other videos, and we're going to put the video object in there. So container equals document.get element by ID. And this is going to be other videos. All right, so we have a container. I made a typo, sorry. So we have a container now. Next thing we're going to do is const new video equals document.read element. We're going to make a new video tag in the browser itself. And then we're going to set an attribute to it, new video.set attribute muted. We're going to set that to false because obviously we want to start hearing the other people and not just, well, see the video, because otherwise it's going to get confusing and we're going to think like, hey, why is this not working? And what else we're going to do is we're going to set autoplay to true, because otherwise the video is not going to start playing, which is going to result in the video just standing there and not doing anything at all. You're not going to hear me do that. By the way, autoplay by default is false, which would mean that if you do not do this, it's going to happen, even if you don't put it to false specifically. The last thing we're going to do on the video object is add a last attribute, which is the ID. Why are we adding the ID? Because later on, we might want to remove the video. We don't want it to stay there when the person's actually not there anymore. So we're going to add the ID with the socket ID that we just created. Now, something else important to note that you might run into if you don't append it with something like video is the fact that these are GUIDs. They start with numbers. If you have a HTML ID that starts with a number, it's not going to work anymore. So it has to start with, well, that's why I'm pre-appending it with video. So it starts with something that works. The last thing we're going to do is set our source object. So source object equals our new stream that came in, so event.stream. And then we're going to container.append child our new video. So then the video should come up in our HTML and in our browser as well. The last thing we're going to do in our for loop is adding our own stream to the connection as well. Why are we doing that? Because we want our, well, the guy we're talking to, or the girl we're talking to, we want them to receive our video and our audio as well. Oh, stream. Okay. So what we're doing now is we're looping through all the clients that are in our room. We're checking, have I registered them yet? If so, then we're not going to continue. Otherwise, we're going to try to set up a connection. We're going to listen to messages that are coming in from that connection, ICE candidates, and when the stream has been successfully set up between the two. And we're going to add our own stream to that connection, so the other guy can start listening to us as well. Now, one last thing we're going to do is if count is more than 2, which basically means if there's someone else in the room other than me, then we're going to get that connection of the new guy that joined. So ID, our connection is what we created up here. We're going to check if it's there, obviously. Otherwise, something up there failed, and we're going to get a random error, and everything is going to break, which we don't want to happen. And we're going to create an offer, which is what I talked about earlier. It's the message that I'm sending a friend of mine, like, hey, man, I want to talk to you. Or I want to meet up, is a better way. We're going to do connection.createOffer. It's very convenient, obviously. And we're going to do connection.set local description, which is going to say, okay, this is the way I'm going to talk to the other guy. This is the offer that I sent. And then we're going to actually send that offer to the other guy over SignalR, over the server that we have. Send. This is our signal as well. It's going to send it to that ID. But instead of sending instead of sending our ICE event like we did here, so type ICE, this time we're going to send SDP, and we're going to send connection.local description. Okay, so what we edit now is when there's someone else in the room, we're going to get the new guy. Well, then we make sure, then we're sure that it's not just us that got the event. Then we're going to get the new guy's connection. If that's not undefined, we're going to create an offer. We're going to send them the offer, and we're going to say, okay, this is the way that I want that my description is. Okay. Now there's one last thing to do. We're going to send these signals about ICE and about SDP to the other guy, but our other guy, which is also the same code, is not going to do anything with them, which could be problematic, obviously. So that's the last thing that we're going to try to implement here. Okay, so the first thing we're going to do is obviously parse the message, because you saw that it's just a string that we're sending over. And then we want to check if that the guy that sent it, because we also know the sender, if that's also myself. So this blocks it basically from sending messages to myself. It's basically a way to prevent errors that I made out of that. Then we're going to get the connection, just like we did earlier, RTC peer connections with the address that's sent from the sender. Then we got to know the message that we got. Is that an SDP message or an ICE message? If it's an SDP message, we can check by checking if it's truthy. So if it's SDP, then we're going to set the connections remote description. Set remote description, new RTC session description, alpha signal.SDP. So now this guy also knows what the remote side is, the way that the remote guy wants to talk. But obviously we got the message. We now know what the remote description is, but we also want to know whether we have to answer the message or not. Because if it already is an answer, I don't see any reason why you want to send an answer again. That makes no sense. That's like sending two messages straight after each other in Facebook when you're trying to meet someone that are basically trying to meet on two different times. Yeah, it's gonna get confusing. So if signal.sdp.type is an offer, then we're gonna create an answer. So const answer equals connection dot create answer. Then we're going to set our local description to that answer, because remember, this is the guy that received the message then. So this guy also has to know like the way the other flow goes to the other side. So local description, set the answer, and hub connection.send. Send the message back over to the other guy so that this guy also knows the remote description. So from, and then JSON.stringify again. It's an SDP message again, and it's connection.local description. Okay. So now we can also receive SDP messages, do something useful with them, and reply if it seems necessary to reply to them. The last thing that we want to do now is check if it's an ICE message and also handle the ICE messages, should that be necessary. So if it's an ICE message, truthy again, then we're going to add an ICE candidate to our connection. ICE candidate. New RTC ICE candidate signal.ice. That's basically it. So this is gonna add another way to for the guys to communicate to each other. Okay, so now this should work. This is basically all the code that we need to let two browsers communicate to each other. We're talking about 122 lines, 21 lines, which you could probably write a bit more properly as well, as I'm not a real JavaScript developer. But let's try. Fingers crossed. So I still do see myself. That's good. Now I should. Yes. Okay. So it works. Let me mute it too because I can hear myself. Okay. So that's basically it. We have two browsers talking to each other over video and over audio. Now, what I would like you guys to try out as well together with me to actually test whether the demo works is I have a link where this is deployed live. I'll put that in the chat as well, that you could check out and try joining in room A. It's going to ask you for webcam and video permissions. But once I join this, I should start seeing other people, and let's hope that this demo works. Either it doesn't work or other people haven't joined the session yet. It doesn't, I don't know, but yay! Okay, we have our first candidate. Someone joined. Okay, so it seems to work just fine. So as you can see, this other person is not in my house or on my same network. We're actually communicating over the internet right now. Can you guys hear me? Okay. Can you try to say something to me? Okay, I can hear you. I can hear you. Okay, so it seems to be working very fine. Jeroen, room A, just the letter A. That should be working. Yeah, I can tell that there is a small delay. Okay. Okay. So we just saw that it actually works, so that's pretty cool, pretty fun. I'm gonna close the room now, and then we're gonna continue the actual talk. Thank you guys for joining. Okay. Okay, that wasn't the idea. Let me switch. Okay, so you can check out my code at my GitHub repository. And you can also try the live demo. They should both work just fine. If you want to try the demo on GitHub itself, make sure to also run the backend and change the URL to the server in the front end as well. Then it should work just fine. Okay, so that was my talk. I taught you about basic WebRTC, how it should work, and how to create a basic WebRTC client with peer-to-peer connections. You can follow me on Twitter or on GitHub. By the way, I'm a .NET consultant at Access. In my day-to-day life, I work on an application to manage big networks. Pretty cool application. If there's anything you'd like to talk about, you can talk to me in the chat right now. I'll answer your questions right now as well, or you can contact me on Twitter. Okay, so the first question that I see from Jesse. In peer-to-peer connections, how can you manage compression and possible cropping of the video sources? Well, you can't do that in peer-to-peer connections. That's why you would go for example, for a selective forwarding architecture or a mixing forwarding architecture. Well, you can, compression you basically can't do, except for the codec that you're using, but you can do cropping, like not actual cropping, but basically just making a frame in your browser that crops it like visually, but it's not gonna, it's not gonna be really good. Which architecture is commonly used in web conferencing tools like Zoom? Well, Zoom has a special setup. I read about that, so I'm not quite sure about how Zoom works. But I would assume that most big companies use things like a selective forwarding architecture or like a mixing forwarding architecture. It's really hard to actually know what their setup actually looks like. But for example, what I do know about Discord basically does it in a whole other way as well. They also use WebRTC. What they do is they send all audio in over multiple lines, but they send it out over another line, and then they have different connections for video and audio. For video and screen sharing as well. So it's a combination of multiple things that they use. It mostly depends on like what you often see in video conferencing tools, that there's different pricing tiers, and you often see that, okay, free tier doesn't support recording, then you're pretty sure that it's not like selective forwarding architecture, or it could be, but it's not, it just doesn't allow recording. The last question that I can see is, which architecture would you recommend for private video calls, like one-on-one calls? Well, still, it depends. If you're building a website like Chatroulette, then I wouldn't go for a straight peer-to-peer connection or a mesh architecture, because that gives away your IP address. If you're building a application to just call to people that you actually trust or actually know, then a mesh architecture would be just fine. But still, then you have to decide between stun or churn, and then it depends. If you want to be a cheap ass, go for stun definitely, because you can use a public stun server. But if you want to make sure that it works on company networks or more restricted networks, then you would probably want to go to something like a turn server or selective forwarding. Okay, another question. If you had to stream VisugXL with more than 400 attendees with WebRTC, can you briefly discuss how complex that would become? Yeah, that's a challenging question. Well, the thing is, it still depends. Like, if you would want to set that up all yourself, like mesh architecture is just a no-go. Unless you're like having small rooms and small conference size, small talk sizes. If you want to go bigger, well, it's difficult to describe how complex it would get, because you're going to have different regions. You're going to have to forward all data between different regions, possibly. You're probably going to have to buffer all your data that's coming in as well in your video sources, because you don't want it to stop playing because there's not enough cache available. You haven't cached enough, sorry. Yeah, you also want a lot of storage for recording. Yeah, it's really difficult for me to describe how complex that would become, because I'm not the biggest WebRTC expert either. So if you want to talk to me that later on, feel free, and I'll try to give you more in detail. If there's other questions, feel free to let them in. I'll wait for just like 20 seconds or something. If there's not, then I'll end the talk. Okay, I think that's it then. Thank you for watching and listening. I hope you enjoyed it. I hope you learned a little more about all the tools that we're using during Corona. If there's more questions, feel free to contact me on Twitter or whatever medium that you want to use to contact me. Okay, thank you.
Thank you, Lode. All right, so the next session will begin in a little more than 20 minutes. So feel free to visit our partners in the meantime, or you can also have some chats with some other attendees via the random networking.